For this video, we are going to be discussing parallel lines and the angles that they form. Now, before we start talking about parallel lines, let's first revisit some angle pairs that you should already know. So the first one we want to revisit is vertical angles. And vertical angles are angles that share a vertex and are across from each other. So these two angles here in blue, they're vertical, and so are these red angles. And they're congruent, meaning that their angles have the exact same measure. Complementary angles are angles that add to a right angle. They add to a 90-degree angle, so their measures add to 90 degrees. And supplementary angles add to a straight line, so their measures add to 180 degrees. Now these are relationships you should already know. Just a quick review. So when parallel lines are cut by a transversal, this red line here is a transversal. It's just a line that crosses two parallel lines. When lines are cut by a transversal, they form several pairs of angles that have special properties. And we're going to be talking about 4 of these angle pairs. So, one set of angle pairs formed by parallel lines in their transversal are called alternate exterior angles. So alternate exterior angles are angles that are outside of the parallel lines and on opposite sides of the transversal. So they're on the outsides of the lines and on opposite sides of the transversal. So if I look here, like angles 1 and 7 are alternate exterior angles, and angles 2 and 8 are also alternate exterior angles. And these angles are congruent, so their measures are the same. If this angle, angle 7, is 120 degrees, then angle 1 is also 120 degrees. If angle 2 is 60 degrees, then angle 8 is 60 degrees. So that's how alternate exterior angles work. There are also alternate interior angles. So the alternate interior angles are also on opposite sides of the transversal, but they are inside of the parallel lines. So like angles 4 and 6, you can see are on opposite sides of the transversal, and they're inside. So are angles 5 and 3. And these angles are also congruent. So whatever the measure of angle 4 is, that's also the measure of angle 6. Whatever the measure of angle 5 is, that's also the measure of angle 3. So alternate interior angles have basically the exact same relationship as alternate exterior angles. They're just inside of our parallel lines. Our third type of angle are consecutive interior angles. So consecutive interior angles are once again angles that are inside of our parallel lines, but they're on the same side of the transversal. So like this green and this orange and this green and this orange. And their relationship is that instead of being congruent, they are supplementary. They add to 180 degrees. So you can see in this picture, like this angle is 116 degrees, this angle is 64. Add them together, you get 180 degrees. These are the only pair of angles that we're going to talk about that have this property that they're supplementary. So instead of being equal, they add to 180 degrees. And our final type of angle are, this shouldn't say consecutive interior, this should say corresponding. So corresponding angles are angles that are at the same location but on different vertices. So if we take a look here, angle 1 is up at this vertice up here, and it's like the top left angle. And angle 5 is down at a different vertice, but it's still the top left angle, meaning angles 1 and angle 5 are corresponding. They're at the same location but on different vertices. Likewise, angles 2 and 6, angles 3 and 7, and angles 4 and 8 are also all corresponding. And once again, they share the property that they are congruent. So whatever the measure of angle 1 is, so is the measure of angle 5. Whatever the measure of angle 4 is, so is the measure of angle 8, and so on. So this table here kind of just shows you the overall view of this. Congruent angles are alternate interior, alternate exterior, and corresponding. And consecutive interior are the only pair that we're going to talk about that are supplementary. And these are the relationships you need to know in order to solve the problems for this unit. So let's take a look at an example. Example 1 says, given that lines M and N are parallel, so here's lines M and N are parallel, and they're cut by a transversal, we want to find all of our missing angles, and we've got 7 of them. All right, well, where do we start? There are actually quite a few places we could start on this one. I've got 112 here, and using 112, I can pretty much find every missing angle. So let's think about this. How can we do that? Well, I can tell you that this angle right here is also 112 degrees because this angle and 112, those are corresponding angles. So because they're corresponding, they have to be congruent. Okay, what else can we do here? Well, I can tell you that this angle right here, well, that's, oh, if I can get it, this angle right here, that's also going to be 112 because these two angles are alternate interior angles, meaning they're going to be the same. All right. Well, there's one more 112 here. That's this guy. Now, there are two ways I could come about this one being 112. It's vertical with my 112 I was given at the beginning, so that's easy. I could say that it's also corresponding with this 112. Or there's actually a third way. I could also say it's alternate exterior with this 112 up here. Any of those ways will give me my missing side, or my missing angle. So now I still have four other angles I need to figure out. Well, using consecutive interior angles, I know that 112 and whatever's over here have to add up to 180 degrees. Well, 180 minus 112 is 68 degrees. So if this one's 112, then this one's 68. Now that I know that, I can find out all of my other angles. By corresponding angles, this guy is 68. By alternate interior, this one is 68. By alternate exterior, or by corresponding, oops, this one is 68. Now you can see that using my one original angle, I could find all of the other ones around here. So that's all we have to do. Let's take a look at example 2. In example 2, we're trying to figure out what value of x will make lines M and N parallel. All right, so we know this angle here is 5x degrees. We know this angle here is 9x plus 40 degrees. All right, so if we could find some way to relate these, we could probably figure out what x is. However, these two angles don't fit into any of our angle pairs. So that makes this a little more difficult. But if we think about this, we know that if this angle here is 9x plus 40 degrees, then by vertical angles, so is this angle here. Right? Vertical angles are congruent, so their measures are the same. So if this is 9x plus 40, so is this one. All right, well now, my 5x degrees and my 9x plus 40 degrees, these are now corresponding interior angles, meaning we know they're supplementary. So I'm able to set up this equation. Because they're supplementary, I know 5x plus 9x plus 40 equals 180. Well, this is a fairly simple equation to solve now. Combine my like terms, I get 14x plus 40 equals 180. Subtract 40 on both sides, I get 14x equals 140. X equals 100, or x equals 10 degrees. Or x equals 10, sorry. So all I did is I used the fact that I knew these two were vertical, so they're the same. That I knew these two were same or corresponding interior angles, meaning they're supplementary, and then I just set up my equation and solved. So here is tonight's try it problem. It says, using what we know about parallel lines and transversals, you need to find the values of x and y in the picture below. And I forgot to put this in the problem, but you can assume that these two lines are parallel.